Hi, and welcome back to the Save It for Parts channel. When I do videos on space radio, satellite topics, things like that, I occasionally get requests to do things a little more, let's say, science adjacent. Stuff like UFOs, alien phenomenon, wormholes, mysterious satellites, things of that nature. Now, personally, I'm kind of a skeptic when it comes to paranormal type stuff. UFOs, yeah, there could be some secret government projects out there, but I kind of doubt aliens are coming here and flying around just to confuse people with bad cameras and abduct some cows. However, it does seem to be a pretty big topic, and there are shows on the History Channel along the lines of Skinwalker Ranch. If you're familiar with the show, then you've probably actually seen it more than I have. I've only caught a few episodes, and I'm vaguely familiar with the show. To me, it looks like typical modern day science adjacent entertainment. It's kind of a tax write-off for a property owner who wants to make a video about some rumors and legends. They get to buy expensive equipment like radios and bulldozers, and since they're doing a show about it, it's all tax deductible. I did a little bit of research on the property, and it seems like most of the rumors about Skinwalker Ranch came from one caretaker in the 1990s. They drummed up enough interest that they were able to get Robert Bigelow to purchase the property. He's the guy that's coming up with inflatable space stations and trying to do commercial space hotels. He wasn't able to find anything, so he sold it to this other group, and now it's a TV show. Anyway, the point of this is several viewers have asked if I could look into some of the radio stuff that they show on Skinwalker Ranch. They use RTL SDRs, they use software-defined radio, much like I do, and they supposedly pick up some strange signals. So people want to know, can I pick up strange signals like that? Dave from Yuma, Arizona was so interested that he actually sent me an antenna that is tuned to the 1.6 gigahertz frequency, which shows up apparently quite often on the Skinwalker Ranch show. So this is a commercial Yagi antenna, very interesting one. Like I said, I'm kind of a skeptic, but I can't pass up a free antenna, so I'm going to see what I can do with this. Dave also sent me this LNA, or linear amplifier. This one is tuned for satellite navigation systems, so GPS, GLONASS, Baidu. I might be mispronouncing that last one, but the US, Russian, and Chinese GPS equivalent satellites, they all use a very similar frequency range that's close to that 1.6 gigahertz. So this little amplifier is supposed to eliminate interference from other systems, amplify signals in the 1.5 to 1.7 gigahertz range, and let us see those signals a little more strongly with cheap equipment like an RTL SDR. Now, while I have an RTL SDR, I also have a Hack RF1. Newelec sent this to me because they were so excited about me showing off some of their other equipment, like their LNA products, and I've been just looking for an excuse to try this out. So this is a little more powerful, a little more flexible, and it has a lot more features than the RTL SDRs that I've been using before. This thing's a little bit bigger and it's a little bit more expensive, but like I said, it's a lot more flexible. Now, I just remembered I was going to involve one other piece of equipment with this video. This is a wireless microphone system that viewer DJ sent to me, so thank you again, DJ. I've had some complaints about my audio quality. I usually just use a little fuzzy rabbit microphone on top of the camera. That's what I'm recording with right now. So I'm going to switch over to this wireless mic, so in the next shot you can hear what that sounds like, and I won't necessarily know what it sounds like until I start editing. So you guys, please tell me in the comments, do you prefer the sound of the fuzzy rabbit on camera mic that you're hearing right now, or do you prefer this wireless lapel mic that I just switched to? Again, let me know in the comments. I have to admit, I have an ulterior motive for using this. In addition to it potentially having better sound, I've noticed on shows like Skinwalker Ranch that the cast and crew use microphones like this. They're around 2.4 gigahertz. They are transmitting the actors or documentary subject's voice off to the camera, and these are potential source of radio interference. So when I did some of the research on this particular show, a lot of people said, hey, maybe their wireless mics are causing interference. Other people were saying, hey, maybe there's the wireless cameras that they use are causing interference, their laptops are causing interference, cell phones. Other equipment could be creating strange signals out in their area. I've also come across one or two posts online of people hinting or claiming that they or people they know go out to Skinwalker Ranch and screw around with ham radios just to mess with the show. I don't know if that's true or not, but knowing radio people and knowing people who live near places like that, I could definitely believe it. I know some people who have created fake UFOs, who have created hoaxes, for things along that line, just to get a rise out of researchers or TV shows, things of that nature. So again, I'm not saying that the show is fake, but people in the area might be contributing to some of the mysterious things that they're seeing. So I'm going to fire up the cyberdeck that I built for snooping on mysterious radio signals. It's still kind of a work in progress, but it does pretty well at looking at satellite things and running my microwave imager. For my initial first look at this thing, I'm just going to set the HackRF in my window with the default stick antenna it comes with. And we've pulled up 1.6 gigahertz on GQRX. We're already getting something weird. We've got this central peak and we've got these moving signals here. So that's really odd. We've got this big lumpy signal that seems to be kind of moving and decreasing. We've got this other lump. Now I have a suspicion about this particular one. If we just go up by a megahertz and back down, that lump is gone. So that particular signal there was just an artifact of my own system. That was just the SDR warming up. That was some kind of internal reflection. Once we tune up and down a little bit, it goes away. In the show, they've gone from about 1.6 up to 1.68, so we can just see if there's anything interesting that the HackRF can see right here inside the house. We definitely have a few little signal blips here and there. As I may have mentioned, this central spike here is an artifact of the DC voltage going into the SDR, and you get that with every SDR. Sometimes you can turn it off if we click on DC remove. It doesn't really help on this one. It goes down a little bit, but we still have this little dip in the very center. And yeah, that's just kind of how every SDR works. They all do something like that. Like I said, there are one or two little blips here, but they're not anything super exciting. If I zoom in on one like this, that looks like interference to me. That is a pretty typical look for a random voltage somewhere in my system, static essentially. Now, we're probably not going to get much inside the house unless we start moving this unit around. If we put the antenna closer to some of our equipment here, I don't know if you can see through the tangle of USB cables, this interference pattern increases if I get the antenna near to the computer. So this is definitely something coming from my CyberDeck, my Raspberry Pi. Actually, that pattern gets even stronger if I put the antenna near my smartwatch. So that's probably coming from my body, my smartwatch here. Now, if we jump up into the Wi-Fi band, 2.4 gigahertz, you'll notice all kinds of stuff happening. So this is kind of what Wi-Fi looks like. And again, this wireless mic that I'm wearing is right in that 2.4 gigahertz Wi-Fi range. So I could be receiving the mic, I could be receiving my own internet. And this particular signal, right around 1.6 gigahertz, that looks very similar to Wi-Fi. So it's not necessarily Wi-Fi, but it could be a reflection, it could be a harmonic, it could be something relating to signals in my own environment from my own equipment. And what I'm trying to say here is this is kind of similar to what the guys on the show do. They've got their RTL SDR set up with the regular old rabbit ears antennas, and they've got it right next to all their other equipment. They've got their laptop, they've got their walkie-talkie, they've got some kind of Bluetooth speaker, they've got some other radio transmitter thing right next to the rabbit ears. Not a super professional setup, not even really a ham radio grade setup. This is some guys that found an RTL SDR and are experimenting with it for the first time. And that's great if you're a first-time experimenter, but if you're trying to do a serious scientific-ish show, something like this is a very clumsy setup. Now, I certainly can't claim that I'll be any less clumsy or less amateurish than the guys on this show because, for example, I'm trying to hook up to the Augie antenna here, and I have this absolute horror show of adapters to go from the in connector down to the SMA connector. Stuff like this can introduce interference, it can create line loss, it can cause all sorts of problems, and I really hesitate to do things like this, but I don't have any smaller series of adapters to go from this end to that end, so this is what we have to work with. Okay, we've brought the antenna outside, we've brought the CyberDeck outside, we've got the HackRF1 set up, and it is hot out here. It is early morning still, and it is like already 90 degrees. I'm kind of regretting filming this in late July. I've been telling people on the comments that I like to do my satellite and radio experiments in the winter, in the fall. When it's nice and cool outside, I can go out and stand around, wave an antenna around without dehydrating and overheating immediately. In the summer, I like to do boat projects, so I've been doing some of those, but people keep demanding more and more satellite stuff, so here we are. I'm also realizing the little baby screen on the CyberDeck does not lend itself to filming. The CyberDeck works great even in the hot sun. It has not overheated, which people have asked about. It's just a Raspberry Pi in there with no heat sink, no ventilation, and it works just fine outside in the sun for some reason, but it's really hard to film. So I might switch over to a laptop at some point just because that's a little bit easier to deal with, easier to film. You'll notice we got that same distortion pattern immediately when we turn this thing on. I've been aiming this thing up at the sky and kind of sweeping around. I'm really not seeing anything at that 1.6 gigahertz range. Now, while the CyberDeck and the Raspberry Pi are doing fine and not overheating, I am overheating. I've been outside for 5 minutes. I am already just absolutely soaking in sweat. I am disgusting. I hate this, and I'm very much regretting doing any satellite stuff outside in the summer. I still want to do this though, so we're going to try and come up with a way to remotely aim the antenna, similar to my L-band satellite dish here. We're going to use this guy that I showed off in a prior video. This is a Fujinon pan tilt controller, again meant for a TV camera or security camera, similar to the other one here. This one is not computer controlled. It's pretty much fully manual with this little joystick situation, but this means I can set up the Fujinon outside with the L-band Yagi, and I can sit here in the garage where it's a little bit cooler, I'm in the shade, and I can run the antenna from back here. Now, we don't get a lot of strange military vehicles here, but you know, we get the occasional black helicopter going over the house. There's a National Guard base just over there, so yeah, these come by all the time. So I've got my little command center set up just inside the garage where I can hide in the shade. And then out here in the yard I have my pan tilt unit with the antenna strapped to it, so I can sit here in relative comfort and aim the thing around wherever I want. Now you'll notice everything is held together with zip ties, and it's mounted onto my favorite professional antenna mount, some milk crates. So I'm just as half-assed as some of the things they do in the show. Unlike the show, I am making an effort to separate sources of possible interference. So I have the SDR sitting up here as far away from the laptop as I can get without resorting to really long USB cables, which I've had trouble with in the past. I have the antenna cable on the right here, separated from the control cable for the pan tilt unit. I'm trying to keep some physical separation between antenna signals and control signals just to avoid any crosstalk there. And then my antenna system is about 12 feet away from the laptop and the SDR, so I should be minimizing some of the localized interference from my equipment by having it out there. So on the laptop, I'm using SDR++ to look at that Hacker F1. And we're getting some really crazy stuff here. We're getting all these great swooping signals and just wacky stuff going on. Again, because these signals are centered right where I started my frequency here, I think that these are interference. And look at that. That looks like my voice pattern. If I just change frequency slightly, all of that goes away. So this weird swoopy stuff is just internal interference, and I do apologize for filming the screen like this, but I still struggle to get screen recorder programs to work reliably, so for now this is how I'm going to do it. I've waved that antenna all over the sky. I have gone all over the spectrum from 1.6 to 1.7 gigahertz. I'm not seeing anything out here. However, we're also not using the LNA yet, so let's pop that into the antenna line and see if that changes what we can see. This LNA has the added benefit of eliminating most of the adapters I was using. Okay, slight problem. I think I've broken Dave's LNA here. The RF socket on this side just fell off. I think I had too much stuff hanging off of it, or there was too much stress from that antenna wire, and the solder joints broke. So I'm going to try to reattach that and mount it again in a way that puts less stress on that connector. I have to say, even with that LNA hooked up and apparently working, I'm really seeing nothing else on the 1.6 to 1.7 gigahertz band. Now here we're getting some interesting stuff. We've got these signals coming in right around 1.6 gigahertz, actually both sides, and they came on for a while and then they stopped. Now I happen to know what that is. Since I'm an American, I microwave my tea. And yes, I can hear every
British follower unsubscribing right now. I own a kettle, I'm just too lazy to use it. I've run into this before when I was looking at 1.7 gigahertz, when I was looking at some satellite stuff and doing some microwave imaging. I could actually tell when the microwave oven was running because it would show up on my microwave scanner as this high intensity, strong signal. So these definitely put out some interference. As soon as the microwave oven turned off, that interference went away. So I'm pretty sure that's where it was coming from. I have to say, so far I'm kind of disappointed in this. I'm not seeing any really weird signals. I'm really seeing almost nothing at all between 1.6 and 1.7 gigahertz with this antenna, with this LNA. So I'm going to try a different LNA. This is a wideband Nuelec Lana, or LANA, and they sent me this along with the HackRF1 to try out. I have not tried one of these before, so we're going to pop this into the antenna line. Now this will not filter out stray signals. This will just amplify everything as far as I can tell. So we might actually get more interference from cell phones, from televisions, from passing aircraft, from industrial users, from all kinds of stuff here in the city. And for the purposes of a TV show where you're trying to pick up weird radio signals, maybe that's what we want. Maybe we want weird interference to show up. All right, we've got the Lana hooked up there at the bottom of the shot, and we're just going to scan around the southern sky again, see if we can pick any signals up. Now you might think we're a little bit too far from Utah, where Skinwalker Ranch is located, to get any of the same signals they're getting, but Dave is in Yuma, Arizona, and he said he could get some of the same signals. Other people online have claimed that they're seeing similar things on similar frequencies. I've messed with about every setting I can find on here, LNA gain, VGA gain, and the only thing I can get are these little spikes that just look like Wi-Fi. Some of the problem with this is that the FCC has been auctioning off a lot of these same satellite frequencies to cell phone companies. So we're going to be seeing more and more interference from 4G, 5G. All the cell phone companies are super greedy about the spectrum, and they keep interfering with more interesting uses like weather satellites, like stream gauges, like stuff that's a little bit more important than downloading cat memes on the go. If we look around at the spectrum, we can get some legitimate space-based stuff with this antenna and this LNA. We've got 2 gigahertz Earth to space, space to Earth communication. Since we haven't had much luck with either of those LNAs, I'm going to try one more Nuelec product, the Sawbird GOES. We're going to aim this at the GOES East satellite and just see if we can get anything out of that. Now, with all the gains close to maxed out, we are actually getting a very faint signal from GOES East. So unfortunately, I'm getting very little out of this antenna. It does work, it does get some space-based stuff, but it's not very effective for the satellites that I know to look for, and I'm really not finding anything else that's suspicious enough or mysterious enough to be able to investigate further. To look at some other satellite things, let's take a look at the big dish here we've got up on the roof. So I'm going to run up on the garage roof. Now normally I've got this guy hooked up to a Raspberry Pi in the equipment box here, but just for experiment's sake, we're going to shut that down and we're going to hook up the big antenna to the HackRF. You can immediately see the GOES satellite is coming in loud and clear. We have that HRIT signal, we've got that side signal, we've got some other satellite stuff up here on 1.7, and we still have all the same blippy interference from 4G and Wi-Fi and whatnot. What I'm not seeing is any kind of mysterious space-based signal that I can't identify. I kind of know what this stuff is just from experience, from looking at it, from experiencing it every day, every time that I use an SDR in the city. I get the same kind of city-based interference. Another thing I want to look at here is that 1.68 gigahertz, 1680 megahertz. That is another frequency that's supposed to be really interesting on the Skinwalker Ranch show. And indeed, at 1.68 gigahertz, we're seeing all kinds of stuff happening. So what the heck are we seeing here? There are all kinds of signals coming down at about 1.68 gigahertz from the GOES East satellite. To find out what these are, let's go on a little field trip. All right, so this thing is a USGS stream gauge. This is hooked up to a sensor down in the creek down there, and that measures the water level. And then the way that gets back to the head office is through this little satellite transmitter. So that is beaming up to the GOES satellite. I actually ran into some USGS employees in this van, but they're doing water quality sampling and they're not directly involved with the stream gauge, so I may have weirded them out a little bit. I gave them a card for the YouTube channel. All right, so that was a little bit of an awkward conversation.
I am not the most articulate in person talking to people, and when some rando like me rolls up on some government employees and starts asking questions about their L-band satellite uplinks, it makes everyone pretty confused. So hopefully I made their day a little stranger. I've come back when they're not around and brought my laptop and the SDR, so that doesn't look weird at all. So I think this guy transmits around 401 megahertz. All right, there was our transmission. That was super strong. So that came through right at 11:05. So as I kind of suspected, these don't all transmit right on the top of the hour, or there would just be too much coming into the satellite all at once. But that was a really brief burst, just a quick uplink, and all it really needs to send is the stream level. So yeah, it doesn't take too much. So according to the USGS website, there are something like 27,000 of these DCP devices, and they are sending up all kinds of data, everything from stream gauges, snowpack, water flow rates, all kinds of stuff that's really interesting for weather forecasting, for climate recording, for scientific purposes. So it's going up at like 401 megahertz, 401 to 403 megahertz, coming back down at around 1.68 gigahertz. I tried running my baseband recording through SatDump with the DCS output enabled so I could try to get some of that DCS data into a form that I could maybe decode, but it looks like the signal was not quite strong enough. Just out of curiosity, I ran the 401 megahertz signal that I got from that stream gauge the other day through SatDump using the same demodulator plugin. Nothing happens for a while because we've been listening to dead airspace, but right at the moment that that transmission goes up, you'll see we actually get a signal here, and we actually get a sync for just a moment. Well, I don't know where else to go with this video. I tried my best to find anything on that 1.6 gigahertz frequency that's supposed to be active and mysterious out at Skinwalker Ranch, and we don't see anything here in Minnesota. The only thing I can see on there is Wi-Fi interference, microwave oven interference, interference from my little wireless microphone, just general noise. And any of that could be showing up in the show. If they're showing a strange radio noise, well, they don't really investigate it any further than just saying, oh, it's mysterious. They don't try to narrow it down to see, is it their laptop? Is it their wireless mics? Is somebody running a microwave back in the crew trailer? Is there an airplane passing overhead? There are a million things that could cause interference on basically any frequency, and unless you're doing a really rigorous investigation and trying to narrow down all of the variables, you can get kind of anything you want out of an SDR signal. You can see interference, you can see weird signals anywhere you look, and depending on how you look, depending on how carefully you look, you can really easily get yourself confused by it. Now, I did learn a little bit more about stream gauges, and I found some interesting signals on 1.68 gigahertz. That's another one they mentioned in the show. Most of the traffic on there is the stream gauge stuff. We went and found one. We saw what that looks like on the uplink. We saw what it looks like on the downlink. That's kind of cool. I don't know if that's what they're seeing on the show, but it's definitely a possibility. I do have to apologize to Dave, who sent me this antenna. I really tried my best to get something out of it, and I wasn't able to get much out of it, with or without the little LNA. I did break the LNA. I think I fixed it, but even using some commercial grade LNAs from New Elec, I was not able to get very much out of that antenna. We could barely see GOES East if we used a GOES LNA. Couldn't get any data out of it. The actual satellite dish worked much, much better for satellite-related signals. Thank you again to Dave from Yuma for sending me the antenna and letting me play around with it. We may or may not have it show up in a future video if I come up with other uses for this thing, if I figure out something interesting to do with it. Thank you again to New Elec for the Hack RF1. This thing has been really fun to play with. There's still a learning curve with it for me. I'm still learning all the settings, how to adjust things, and I've been playing around with that more and more, so we'll be using this for future videos as well. And again, to any fans of the Skinwalker Ranch show who might say that I did a bad job of this, or that I'm just trying to myth bust it or whatever, you know, I had an open mind. I didn't set out to prove or disprove anything. I just wanted to see what signals can I see at that frequency. Can I see anything from here in Minnesota on that frequency? And I really couldn't. I tried this at different times of day. I tried different gain settings. I tried different orientations of the antenna. I tried different directions for the antenna, different LNAs. Nothing really worked. And all I could really pick up with that were known and identifiable signals like the weather satellites,
cell phones, microwave ovens, general, everyday, normal stuff. Nothing too exciting, nothing paranormal, nothing that I would say is out of this world. I'm sure I'll get some comments from fans of the show saying I should have tried X, Y, or Z, and I'll probably get some other comments saying that it's all baloney, and maybe there'll be a little flame war in the comments. Hopefully not. I get tired of deleting that when it gets too rowdy, but anyway, we'll see what happens there. Stay tuned to see what other videos I come up with on the topic of satellites and space radio and other radio subjects. Again, some of those might have to wait for the winter because it is uncomfortably warm outside, and I kind of hate Minnesota summer. I don't want to be outside in it. So we'll come back to some satellite stuff maybe more in the fall, or depending on what else I have going on here. And then again, just like I said at the beginning of the video, let me know if you prefer this microphone
or this microphone, the fuzzy rabbit that's on top of the camera right now.
Thanks to everyone for watching, and we'll see you next time.